Hello everyone. This is the second video in a series dealing with an introduction to vehicle stability. In this video we will learn about the wheelbase of the vehicle, and its effect on the stability of the vehicle. We will learn about Euclidean space and Euler angles, and their use in analyzing the movement of the car. The wheelbase is the distance between the front axle and the rear axle of the car. Euclidean space is the space as conceived by the mathematician Euclides, who divided the space into length, width, and height axes. In this video we will discuss the wheelbases of different kinds of vehicles, Euclidean space and Euler angles. The wheelbase of a vehicle defines the stability of the vehicle. The wheelbase is the horizontal distance between the middle of the front axle and the middle of the rear axle of the vehicle. A one-wheeled vehicle. For example, a unicycle. This type of vehicle has only one axle, so its wheelbase is point-based, and its stability is not related to the real wheelbase, but is mainly related to the skill of the rider. When the rider feels that he tends to fall, because his common center of gravity in the unicycle is not above the point of contact of the wheel with the road, he drives the wheel forward or backward by pedaling, in order to return the descending vertical from the center of gravity to the point of contact of the wheel with the road. When a unicycle rider feels that he tends to fall sideways, he tilts his upper body against the direction of the fall, and in addition he rotates the plane of the wheel, by rotating his upper body, and after the plane of the wheel aligns with the direction of the tendency to fall, the rider again moves the wheel forward or backward by pedaling, returning the descending vertical from the point of center of gravity to the point of contact of the wheel with the road. Two-wheeled vehicle. For example, bicycle, or motorcycle. Those are two-axle vehicles, with the front wheel axle being the front axle, and the rear wheel axle being the rear axle. The wheelbase in a two-wheeled vehicle is the distance between the center of the front wheel and the center of the rear wheel, which are the contact points of the tires on the road. With a two-wheeled vehicle, the wheelbase is relatively short compared to the height of the center of gravity, which makes it easy to lift a front wheel, which is called wheelie, or lift the rear wheel, which is called stoppie. The wheelbase in a two-wheeled vehicle, together with the height of the center of gravity, has a great impact on the longitudinal stability. Four-wheeled vehicle. For example, passenger vehicles, commercial vehicles, buses, etc. The front axle has two wheels, and the rear axle has two wheels, and the wheelbase is the distance between the middle of the front axle and the middle of the rear axle. The trace width track is the measured distance between the center of the right wheel and the center of the left wheel. The footprint of a car is the area defined by the contact points of the four wheels on the road. The footprint area is obtained by multiplying the length of the wheelbase by the width of the trace. In a vehicle with more than four wheels, for example a truck with 6 or more wheels, the wheelbase is the distance from the front steering axle to the center point of the rear axle group. Rule of thumb: the longer the wheelbase, the more stable the vehicle. Also, the wider the width of the trace, the more stable the vehicle. The Greek mathematician Euclides divided space into 3 dimensions: length, width, and height. Determine Euclidean space so that each point in space can be defined by 3 axes perpendicular to each other. The longitudinal axis is marked with the letter X. The lateral axis is marked with the letter Y. The height axis is marked with the letter Z. We will use the definitions of Euclidean space to analyze the data of the vehicle, where the first axis is the point of the vehicle's center of gravity. The x-axis is the longitudinal axis of the vehicle that crosses the center of gravity point. The y-axis is the vehicle's latitude that crosses the center of gravity point. The z-axis is the height axis of the vehicle that crosses the center of gravity point. Swiss mathematician Leonhard Euler used the principle of Euclidean space to describe the rotation of a car in 3 dimensions around each axis. In the professional literature, it can be seen that the more common use of Euler's model is in the aviation industry, but is also used in the automotive industry. The difference between the two branches is that in an aircraft the rotation around the axles is pure, in high flight in the air, while in a car the rotation between the axles is carried out with the wheels of the vehicle supported on the ground. The longitudinal axis is parallel to the ground, passing through the car's center of gravity. This axis is perpendicular to the other two axes. Rotating the car around the x-axis causes the car to roll sideways, left or right, and is therefore called roll. Positive roll and negative roll. In a positive roll, the left side of the vehicle rises, and the right side of the vehicle dives. In a negative roll, the right side of the vehicle rises, and the left side of the vehicle dives. When side forces act on the vehicle, pushing the vehicle's center of gravity sideways, the vehicle tends to roll in the direction to which the side forces act. In an extreme case, where the vehicle's center of gravity exits outside the wheelbase, the vehicle flips over on its side, and roll over. Also called lateral axis, or transverse axis, it is an axis parallel to the ground, passing through the car's center of gravity. This axis is perpendicular to the other two axes. Rotating around the y-axis causes the car to swing forward or backward, and is therefore called pitch. Positive pitch and negative pitch. In a positive pitch, the front of the vehicle rises up, and the rear of the vehicle descends down. In a negative pitch, the front of the vehicle descends down, and the rear of the vehicle rises up. When the driver applies braking force, the vehicle's center of gravity moves forward, the vehicle pitches forward, creating a diving of the front of the vehicle and elevation of the rear of the vehicle. When the driver applies acceleration force, the vehicle's center of gravity pitches backwards, creating a diving of the rear of the vehicle, and an elevation of the front of the vehicle. Also called normal axis, the vertical axis is a hinge that is perpendicular to the ground, passing through the car's center of gravity. This axis is perpendicular to the other two axes. Rotating around the z vertical axis causes the car to rotate left or right, and is therefore called yaw. Positive rotation and negative rotation. In positive rotation, the vehicle rotates clockwise, meaning that the front of the vehicle moves to the right. In a negative rotation, the vehicle rotates counterclockwise. That means, the front of the vehicle moves to the left. When the vehicle is in motion on a curve, and a state of oversteering is obtained, a fishtail is caused in the opposite direction to the direction of turning the vehicle, and the vehicle rotates around the vertical axis. That means, the vehicle yaws. Such a driving mode is considered dangerous, and the driver may lose control of the vehicle. If you liked this video, please like. I invest a lot in publishing professional material for free, for everyone. I wish you to subscribe to the channel, and turn on the bell, so that you will receive notifications each time a new video is published. Please share with your friends, and I would love your comments as well. This will help a lot with YouTube's algorithm. In this video, we learned about the wheelbase of the vehicle, and the effect of the wheelbase on the stability of the vehicle. We learned about Euclidean space and Euler angles, and their use in analyzing the movement of the car. I hope you will benefit from the information learned. And until next time, drive carefully.